All right, welcome everybody. Thank you so much for joining today for Creating Polished Concrete Chemically. It's presented by Premera Coatings. We've got Doug Foster here today, who's going to be presenting today's topic. And let me see if my colleague Helen is joining. No, I'll go ahead and give a quick intro about Acelab. So my name is Bo. I'm here with Acelab. We're helping out with hosting today's event. And I'm going to give a quick few-minute intro to show you how to find Premera Coatings on Acelab. So if you have any questions after today's webinar, that's a great place to come to be able to share some project details or just a general inquiry, as well as explore some more about their products. So I'll share my screen, talk through that, and then I'll launch a quick poll after this. So if you're interested in learning some more about how to use Acelab for your product research, as well as scheduling a demo with our team to learn about some of our newer launches and gain some early access as a beta tester to some new features, I'll launch a poll and you can go ahead and reply yes to that. Our team will reach out to schedule some time with you. But everyone who signed up for today's webinar automatically has a free Acelab account made for them. When you log in, you can see an overview of the work you've been doing, research that you've done. You can see your projects. You can also sign up for webinars here. But if you know exactly who you're looking for, you can head to the search bar at the top here. You can type in the name of any manufacturer, make sure you're on brands here, and then head over to their page on Acelab. So from here, you can use this contact button to get in touch directly with Doug. And then scrolling down, you're able to view some more about their company, watch some videos, explore their products, save them to your projects, all right from this page. You can also view some case studies and inspiration. So this is a great place to come to learn some more after today's event, as well as get in touch with Doug directly. And then if you do use that contact button, I just want to show you where that conversation will live. So it'll be over here in your workspace, head to conversations. And here you've got a record of all of the conversations you've been having in Acelab. So it's a great way to keep your communication all organized with your building product research and organized by project as well. All right, so that's it for the quick intro. I will go ahead and launch that poll. So if you're interested in learning some more about how Acelab works, feel free to say yes to this poll and we'll reach out to schedule some time with you. After today's webinar, if you are interested in connecting, my colleagues Helen and Evelyn, who work closely with the architects who use our platform, we'll reach out to help you out with using the conversation portal. Make sure you know how to find everything, but it's super easy to use and you can actually reply directly to the email notifications that'll log in Acelab system as well. So it integrates really well into the rest of the communication that you're doing over email. All right, other than that, I just want to remind everyone to please feel free to use the Q&A throughout today's webinar to submit any questions or comments that you might have. We'll have some time to get to Q&A at the end of today's presentation. And if we don't get to your question live, we'll have a record of it so that we can follow up with you after today's event. So please feel free to submit those throughout the presentation. All right, that's it for my intro. Doug, whenever you're ready, feel free to share your screen and take it away.
All right, sounds good. Well, thank you, Bo, and thank you everyone for joining. Thank Acelab for hosting. They've been amazing to work with, and we're excited to teach everyone about some of the technology we have related to polished concrete. So I will share my screen now, and we'll get this thing going. So we have polished concrete the Premera way. So I'll get into that a bit more, but basically the Premera way, as we see it, is there's a Premera way to do things, right? So this presentation will be about the Premera way to do polished concrete. The Premera way is essentially we're using sol gel technology, which I'll explain more, to tackle these kind of long-standing industry problems, or we're using sol gels to create efficiencies where there's been normally a very kind of arduous, labor-intensive process, and so we're able to use chemicals to basically do a lot of the work that normally required physical or mechanical processes. And so that's what we mean by the Premera way. There's a Premera way to do polished concrete. There's a Premera way to do surface prep. There's a Premera way to do clear coats and other things. This presentation now will be focused, of course, on polished concrete. So diving into this Okay, so just a little bit about Premera in terms of the history and myself as well. So Premera was started by my father, Charlie Foster, in 2012. He innovated sol gels to basically be able to be used in ambient conditions. And so again, there's another slide where I'll talk more about sol gels, but the idea is that he innovated a technology to make it much more accessible and to be actually able to be applied in a variety of kind of these unique applications. And so we had some initial commercial success in automotive, some nuclear energy spaces as well. And then basically we're just really good at kind of catering our technology to fit these kind of bespoke solutions. And in 2020, we finally hit economies of scale to be able to apply our technology to the flooring market, which in the coatings world, the flooring market is kind of the most price sensitive market. And so we had to be making a lot of, generating a lot of volume in order to get our prices down so we could actually go after that market. But in 2020, we successfully did that. That's also the year my father retired. And so now I lead Premera, and I'm responsible for developing new formulas using the sol gels, trying to figure out how to apply sol gel technology to these varying kind of industry problems that are out there, and just generally accelerating the adoption of the sol gel technology that we have. So before we get into exactly what sol gel is, in terms of the footprint that Premera has, we have manufacturer headquarters is in Texas, near San Antonio. We have manufacturing location near San Antonio and Chattanooga, Tennessee. Also Chile that services South America, and Dubai that services the Middle East and Australia. And so within the US, we have about 100 retail locations. We sell primarily through the decorative concrete supply stores. And so we're available in most everywhere in the country at this point. So what is a sol gel? I've referenced it several times. The easiest way to describe it is that it's basically a liquid version of a mineral, right? In this case, it's a liquid version of silicon dioxide, right? So if you shake it up, it's a very low viscosity material. It's about the viscosity of ethanol, but it's entirely comprised of silicon dioxide. And so basically, when you think about sol gels versus other types of flooring products, their floor coatings, whereas epoxies, acrylics, urethanes, typically we're pretty familiar with those things. Those are all types of plastics, right? So epoxy is a type of plastic, urethane is a type of plastic, and depending on the application you have, what type of floor environment you have, it can make sense to use different, epoxies or urethanes based on the characteristics of that plastic that you want. You have a lot of chemical exposure, and epoxies make more sense than a urethane because epoxies are very chemically resistant, right? But at the end of the day, we're mixing A and B together, and it creates a thin film of plastic on the floor, and that's what coatings are. What sol gels are, on the other hand, is instead of a plastic, it's actually a liquid crystal, right? So it's not plastic, it is actually a real mineral, a real liquid crystal that once it's applied and cures out, it turns into a solid quartz-based crystal. And so that has a lot of potential applications. And these are basically the applications. We have a primer, a clear coat, a sealer, but the products that we'll be focusing on today are the densifier and the guard. And so this is a way to create polished concrete in a much more efficient way than the traditional process, which I'll explain a little bit for anybody that might not be familiar with it. But basically, we're creating really significant efficiencies over the current state of the art for at least different types of processes. So moving on into some of the types of substrates that we're able to work with: tile, marble, concrete, painted surfaces, coated surfaces, and metal. we work with all of these types of substrates now. There's our clear coats and primers are applicable for all of these types of substrates. So we do a lot of work in all sorts of types of construction materials, but of course, this is focused on concrete. So we'll move into that. So this is basically kind of the current state of the art, right? If you want to take a concrete slab and polish it, there is a well-defined process to do this, right? It requires some fairly heavy machinery, which you can see here. It's a concrete grinding machine, basically. So essentially the process is you start with a very aggressive grind if you're wanting to expose the aggregate. So with concrete, when they pour the concrete, it's just a big slab and there's a slurry that basically rises to the top of the concrete when it's poured. And so if you want to expose the aggregate, this basically means that you want to actually expose the aggregate that's within the concrete. And the way you do that is you grind through that slurry and you go down and down and down into the concrete until that aggregate's starting to be exposed. And so it'll look like little rocks, basically smooth rocks that are being exposed. And so if you want aggregate exposure, then you start with what's called, typically a good place to start is 30 metal diamonds. Basically, a diamond's just a little puck that goes onto the bottom of the grinding machine, and you're just cutting through the concrete, just trying to take up as much of it as you can, so you can get down to the aggregate and expose it. Then every step beyond that, basically, you're making the surface smoother and smoother and smoother and smoother and smoother, right? And when you're doing this mechanically, there's a lot of steps involved, because to skip any step in between will basically create scratches. So with every consecutive step, basically you're getting all the scratches out of the previous step in the surface, to the point where you're getting every step you're getting more and more fine scratches, until the very end where you're basically just eliminating all scratches, so that the surface is essentially just reflective, right? Like a mirror. So typically, if you wanted to get aggregate exposure, you do that with the metals, and then you go to 100 hybrid diamonds, and then you clean and you apply a densifier, and then you do 200 resins, which is basically a less aggressive type of grind where you're just getting more and more scratches out, and then you want to clean up the slurry. Basically, this step when they go from hybrid diamonds to resin diamonds, you want to start doing it wet. So you basically wet the floor, and then you're polishing a wet surface because it cuts a little bit better. And so the normal process, because you're doing it wet, when you're grinding concrete, it generates a lot of dust. And so all that dust becomes mud, essentially, when there's water involved. So you do the grinding process, and then there's a slurry that you have to clean out, in between each consecutive further step. If you don't do that, then it can be very hard to tell if you did grind a certain area. It can create little scratches because it'll kind of create this like mud that you're pushing into the surface with these grinding machines. So it's very important to clean the slurry up after each step. If you don't do that, it'll basically negatively affect the performance and appearance of the polished concrete down the road. So 200 resin, clean it up, 400 resin, clean it up, 800 resin, clean it up, 1500 resin, clean it up. Sometimes they'll go to 3000 resins to create just an absolute mirror surface, but not always. And then after that, polished concrete, while it's a very laborious process to make it, reflective like a mirror, it is still concrete at the end of the day. Even though it's polished and very smooth, it's still concrete, which means that it can stain pretty easily. And so if you're going to go through all the work of creating polished concrete to begin with, then it makes a lot of sense to go ahead and protect it with the guard, right? We have our own guard, but the idea of a guard is if you drop, wine or some type of food, acid, or drink on the concrete, you want to give yourself some time to be able to clean it up so you don't stain this polished concrete, which took a lot of time and expense to create. And so after all the polishing is done, everything's clean, and typically people will apply a guard and then they'll burnish that, right? So that's the process now. That's the fastest way to do it if you're going to do it mechanically. And we're only people that have it mechanically, so I'll get into that. We're only people that have a chemical process, so I'll get into that now. So the way that Premera polishes concrete with sol gels is it's applied with a pump sprayer, but basically in terms of the steps, before I get into that, if you want to expose aggregate with our systems, then that process, that part of the process is the same, right? The only way to expose the aggregate is to do that aggressive grind, those initial steps. People don't always want the aggregate exposure. Polished concrete can look really, aesthetically pleasing without necessarily having to expose aggregate. It's just kind of a preference of the architect or the building owner or what have you. So if you don't do that, then you can just go, if you don't want aggregate exposed, then you can just go straight to 100 hybrid diamonds. And so the aggregate exposure is kind of an optional step. But if it was just what they call a cream polish, then what you would do is just do 100 hybrid diamonds, which is just one step basically. And then clean the surface. You apply our densifier with a sprayer, with this pump sprayer that you see on the left-hand side of the screen there. And then you wait about an hour, and then you burnish it with a burnishing machine. And the difference between a burnishing machine and one of these heavy-duty grinding machines is two things: cost and size, right? So the cost of a burnishing machine versus the cost of a grinding machine, burnishing machine is about 10% the cost of one of these more heavy-duty grinding machines. A brand new grinding machine can cost anywhere from $30,000 to $50,000. Whereas a brand new burnisher is between $3,000 and $5,000. So basically it means that it's a lot more accessible. It's also a lot smaller and more maneuverable. So if you've got tight spaces and you want to get a big grinding machine into there, well, that's going to be really difficult, if not impossible, which means that the only other alternative at that point is to just use a hand grinder to polish an area, which can be challenging for a couple of reasons. One is it's a giant pain for contractors to actually deliver. And beyond that, it takes much longer, which means it's much more expensive to deliver. And also because it's a smaller tool and there's inconsistent pressure, it can be harder to deliver a consistent appearance, as opposed to using a grinding machine where it's constant head pressure and speed. It just creates a much more consistent finish for polishing. So that's some difference. What we're doing with our products is when we spray our densifier on the concrete, basically our sol gel, which is again a liquid crystal, is going into the concrete and densifying it. But also there's a little bit that's left on top as well, right? And so after that hours passes, that liquid crystal is hard enough to be able to burnish and polish that, right? And so what that means is we're able to basically skip all the way from, the 100 diamond step down to a 3,000 grit diamond pad with the burnishing machine and polish it in just one step, right? And so we're cutting out, the 200 resins, the cleaning, the 400, 800, 1500, and we're doing just apply our densifier, wait about an hour, and then burnish it with a 3,000 grit diamond pad with a burnishing machine, which is a lot more maneuverable. It's a lot faster. So it's a faster process anyways, and we're eliminating several of the steps required. And because our material is literally a liquid crystal, so silicon dioxide, which is the same thing as glass, chemically silicon dioxide is glass, is also the same thing as quartz, right? So because we're polishing literal glass, the effect is that you have this glass polished appearance of the floor. Concrete's being polished to a degree, but also just the liquid crystal is being polished to a degree. After that hour, it's hard enough to be able to polish it. And so you can basically very efficiently create this polished concrete effect without having to go through all of the steps. And then just like with normal polishing, there's a guard as well that I'll get into. We have our own type of guard. It's a little bit different than the kind of more traditional types of guard. But just to kind of bring this home from how long does this take, right, in terms of the process, we kind of built this kind of way to conceptualize it. So if you were to have a 5,000 square foot, say, warehouse or something, lots of open spaces, and they didn't want any aggregate exposure, right? So it's just maybe a salt and pepper finish, but a class A finish. There's 4 classes, class A, B, C, and D, and each class basically tells you how much aggregate exposure you want. So class A is not very much aggregate exposure, or basically there's none. Maybe some salt and pepper, which is the very, very top tips of the aggregate. So what you would do with the conventional polishing process is you'd start with 100 hybrid diamonds. So to do 5,000 square feet of polishing with one, grinding machine, the Levine is the heavy duty grinding machines, it would take you about 1 day to grind the whole thing with the 100 hybrids, right? So then day 2, what you would do is you would clean the surface, apply a densifier, traditional densifier, and then you could get on it that same day with 200 resins, right? So then after that, you clean it. Day 3, you do 400 resins, clean it. Day 4, 800 resins, clean it. Day 5, 1,500 resins, clean it. And day 6, apply a guard and burnish that, right? And that's if you don't want to go to 3,000. You only want to go 1,500, which is pretty reflective. I mean, it's got a really nice gloss to it. So for a 5,000 square foot facility with one grinding machine, it would take about 6 days to polish that to a 1,500 finish with the class A aggregate. So you take that compared with sol gel polishing, you still have to do the 100 hybrid step. So that step is the same to open the concrete up a bit so that our densifier can go into the concrete. Then you apply our densifier. You're only waiting about an hour, and then so day 1's grinding the concrete. Day 2 is you're cleaning the concrete and applying your densifier, and then an hour later you're burnishing with 3,000 grit, and which is a very fast process. And then you basically hit it one last time with a white buffing pad, and then you can apply the guard and burnish that as well. And you can do all of that in the second day, right? So depending on the size of the job and the aggregate exposure that they want, which class of aggregate exposure they want, we can take the time required to polish concrete anywhere from a third of the time to, even less than that sometimes if it's a bigger square footage. The bigger the area, the faster the more time we're actually gonna save, because our process is so much quicker and there's so much less work involved to deliver a very similar type of finish. So to dive into the products just a little bit, more specifically, the densifier is a product that I've been speaking about, where you take the concrete to 100 hybrids and then you apply the densifier. So this is literally a liquid crystal. Using sol gel technology, we're able to create a literal quartz crystal on the floor. After that hour, it's ready to actually polish the material itself. And the result is that you saved a lot of time. You've densified the concrete, which is what you want if you're going to polish it. It's a completely UV stable, kind of industrial grade level of protection to the polished concrete. So it's a single component product. It's very easy to apply and very fast to apply as well. So once that is created, we have a guard as well. So just like normal polished concrete, you create you go through the mechanical process, creating a reflective surface, then you want to put a guard on it to protect it from stains and that type of thing. So whereas most guards are an acrylic, in terms of what the actual guard is comprised of, it's kind of like a wax almost. Most guards are acrylic on the market today. They use acrylics for a couple of reasons. One is acrylics have pretty good adhesion, so they can stick to a polished surface really well. They also can dry fairly quickly, and so you can actually polish them. You can buff them out, right? So you can create a shine with acrylics. And that's the reason that they use acrylics. It's just kind of a useful material for what they're trying to do. They're trying to give you a little bit of time so that that product, wine or whatever, doesn't penetrate into the concrete. It gives you a little bit of time to clean it up, right? The downside of acrylics, and this isn't any product in particular, just the technology of acrylic, the inherent limitation of it is that it's not very resistant to chemicals, right? So, a lot of times nail polish is like an acrylic. You get some acetone nail polish remover, just wipe it off, and it comes off pretty easily. Because acrylics rapidly break down from solvent attack. They're not very chemically resistant. And so when it comes to pickle juice, wine, lemon juice, these common types of food acids that you might see in a cafeteria or on a countertop or in a grocery store, these will break down acrylics because acrylics are not chemically resistant enough to withstand the chemicals within those types of foods and drinks. Right, and so it'll give you a couple hours, maybe. A lot of times, with pickle juice, you have maybe a few minutes. So say you're in a grocery store, polished concrete, you put a guard on it. A week later, 2 weeks later, a jar of pickles falls off the shelf and breaks on the ground. You're going to have maybe 5 minutes to clean up that pickle juice before it goes right through the guard and then etches the polished concrete underneath it, because most guards are acrylic and they're just vulnerable to chemical attack and food acids. So that's kind of the current state of the art with guards. Our guard is, instead of acrylic, it's a polycarbonate. So polycarbonate is the same material that your headlights are made out of. So it's a very robust material. It's very hard, durable, scratch resistant, abrasion resistant, UV stable, but also resistant to food acids, vinegar, pickle juice, limes, that type of thing, right? And so the guard is, because of just the chemicals that we're using, polycarbonate instead of acrylic, it's just a more robust material, right? The reason that people don't use polycarbonates more widely is because it's hard to get a polycarbonate to behave as you'd like to for a guard, which is basically a really easy microfiber wipe-on application. We figured that out, and so because we figured that out, we're able to use it as a more robust material to protect our polished concrete as a result. So another interesting aspect of our guard is that it has this kind of active self-cleaning high pH to it, and so it'll actually eat stains over time. So say mustard or something is on there for several hours, it will actually stain the guard, but basically you run a burnisher over it and the high pH will actually eat that organic material and go to like new after about 4 or 5 days. So it's a very interesting, this kind of unique way to go about guard to protect not only polished concrete created with the sol gel method, with the Premera way, but also the mechanical process as well. So it's just a better material, and so it's a better protective film over the concrete. So this is just, we'll just dive into some of the jobs that have been done out there with the crystal system, so you guys can see what it actually looks like. So this is an example of a Class A finish. So we call it a cream polish, basically. So you can see that there's really no aggregate exposed, right? There's no little chunks of rock that are visible, smooth chunks of rock, but chunks of rock nonetheless. It's just, you can just see that the cream of the concrete was just basically polished, right? So this whole thing, I think it was about 1,500 or 2,000 square feet, was done in 1 day, which is ordinarily, to get this type of concrete to polish in 1 day would be basically impossible. You'd have to throw several machines at it. You'd have to get a bunch of crews out there, and it could technically be done, but you'd have to really be highly motivated to do that. It'd be a lot more expensive to mobilize that many people and that many machines to do this. So with this was just one crew. It was 2 or 3 people. Did the hundreds, cleaned it up, sprayed our intensifier on after an hour, burnished it out, and you have this really high gloss, really beautiful polished concrete as a result. And so from an aesthetic perspective, this is essentially identical to, the mechanical process that is typically done. So I mentioned tight spaces, right? So in relation to getting a burnisher to access an area versus a actual grinding machine, it'd be basically impossible to get one of the more common grinding machines into a space like this and polish it out. You couldn't even turn the thing around. It's a very big machine, right? And so when you have tight spaces, that means that you've got to hand grind it traditionally, and that'll just take much longer to do. It's doable, but it takes much longer. So with this, because of the machine that's required to burnish the densifier that we have is smaller, it's just a lot more maneuverable. And so it's a lot faster because so many steps are no longer necessary to polish concrete, and the machines that we use to actually get buff out are much more maneuverable as well. So this is actually a job done down in Australia. So this is like a class C or class D aggregate exposure. So you can see the aggregates exposed pretty well here. I mean, it's a lot of exposure. So they ground this down with the metals. They took it to 100 hybrids, applied the densifier, and polished it out. And it is true polished concrete, right? This is indistinguishable from the mechanical process of doing it, which would take much longer, generated a lot more dust, a lot more mess, and a lot more time, right? So that's it's Premera system. The Premera sol gel is applicable for A, B, C, or D aggregate exposure. We can polish it all. It doesn't make any difference to us. It's just a matter of how much grinding you need to do to expose that aggregate. This was another very kind of wide open space. I believe it's like a barn dominium type of thing. This is again done in a day. This was, I think, 3,000 or 4,000 square feet. I guess it was done in 2 days. Very simple process. We're just spraying, take the concrete to 100 transitionals or 100 hybrids, spray a densifier, wait an hour, and burnish it out. So whether the job is big or small, it's almost always more efficient to just use the Premera way to generate that polished concrete than the traditional mechanical way. So I'll have some actual demo videos here that you can see the actual application process. They're not very long. It's pretty quick little clips. But this is just applying the densifier. So it's applied with a little pump sprayer here. So it's an acetone-proof pump sprayer. I don't want to make this too loud, so just do that. So I'll just show you guys applying the densifier. So that's as complicated as it is to apply the densifier. So pretty easy, pretty simple. It's definitely something that very accessible kind of skill level required. So basically they did that to this entire area, waited about an hour, and then they're ready to burnish it out. So I'll show you guys what that process looks like. You're just kind of running this burnisher over it, and you're creating this polished appearance, but you're doing it very fast, right? That's the idea. And so, these machines are very easy to maneuver and operate. They're very inexpensive, so it's a lot easier for contractors to deploy many of them to one job, as opposed to, if you wanted to throw 10 burnishers at one job, that's the same cost as throwing one grinder at it, right? And so it's just a lot more scalable because the equipment required to deliver the polished concrete is a lot more accessible. And then this right here is the guard, just to show you guys that. So once this is burnished out, then you just microfiber apply the guard.
And then you can immediately
microfiber. My voice again. All right, so very simple to apply our guard, just a microfiber, just wipe on application, and then you wait like 30 minutes or so, you need to burnish that as well, just like a normal guard. So that's basically as complicated as it gets, right? And so it's when you're thinking about maybe specifying polished concrete. I mean, one of the things that is really important, of course, is who is able to do the work, right? Do they have the right skill level? Can they do it consistently? What if they change crews or they're shorthanded? And is it going to be a problem if their polished concrete crew's tied up? Are they going to have to push the job back? So the skill level required to do this is a normal polished concrete is a limiting factor. It's beautiful. And it's an amazing type of floor. Polished concrete is one of the fastest growing types of floors that there are because it's just very aesthetically pleasing. It is very easy to maintain. You don't have to, take a bunch of other kind of construction materials. If we wanted to put tile or something on the floor, that's a whole other supply chain we have to deal with to put that into install it. So basically, how complicated something is to create limits the amount of people that can do it consistently over time and successfully. So what we've done with the Premera way to create polished concrete is we've made it a lot more accessible for a lot larger pools of people to be able to create polished concrete that performs actually a bit better with our guard than the traditional way, which basically means that it's a lot easier to have a job be done, correctly, with it performing to the degree that you need it to, and so we've just made the entire type of floor a lot more accessible, basically by simplifying the process and putting it in the hands of people that are used to applying much more complicated things or doing much more complicated, painstaking processes. So moving on. We also have a network. We work with a giant franchise company called Concrete Craft, and so they've got over 100 franchisees nationwide, and all of them are able to apply our crystal system. We call it crystal system, the crystal densifier, and the crystal guard. And so this means that while this is great technology doesn't do anybody any good if you can't actually spec it onto a job and have it be done, right? So we've got nationwide coverage of people that are able to do this consistently over time. So we have consistent performance, delivery, and success for you, the contractor, and everyone involved, the building owner. So we've kind of, we've got very interesting technology. It saves a lot of time, creates a lot of efficiency, delivers a much better results, and it can be done, all over the country and now the world as well. But I think we're mostly in the U.S. here, so we'll focus on that. But that is the Premera way to do polished concrete. So if anybody has any questions, we can open that up, and I'll stop sharing my screen now. I'll share.
Right, awesome. Looks like we do have quite a few questions. So if it sounds good, I'll just start at the top and we can kind of work our way through. And if anybody else has some other questions, feel free to submit them now, so we can try our best to get to all of these during the live event. All right, starting off with, are there additives for slip resistance?
Right, good question. So the guard, well, polished concrete is obviously very glossy, highly glossy, right? People can think, okay, glossy surface means that it's going to be slippery. With our guard, the guard actually does have grip to it. It's very smooth and kind of glass-like finish, but it has grab to it. And so despite being very glossy, it has grab, and so it's actually not slippery. It's not a slippery surface. So it's compliant with all the ADA requirements. And so you can use this guard on polished concrete, on tile, on any type of floor, right? And it's naturally slip resistant as it is.
Awesome. All right, what about, you mentioned the benefit for small applications. Could it be used to refinish concrete kitchen countertops?
Absolutely. So with countertops, again, especially if you're going to use some type of other guard product, you're going to run into food chemicals, right? Lime juice, lemon juice. Those are traditionally the things that will really tear up guards very quickly if you wanted to use any other type of guard product. So ironically, even though we can eat the food chemicals and things that the countertop will be exposed to, from a coating perspective, it's actually harder than you might think to actually protect against those. So yes, a countertop, very simple. You just wipe a thin film of the guard down, and then you can burnish that out. If you want it to be really shiny, you can just leave it as is. If you want it to be a little more of a satin finish, so yeah, that'd be a perfectly good application for it.
Awesome. How much prep is required, and do divots need to be filled?
Yes, so the prep basically for the crystal line of products is it just needs to be clean, right? So in terms of where the profile needs to be, it needs to be at 100 hybrids, which is basically one of the first steps, or the first step if they don't want aggregate exposure. So you start there just like you would with normal polished concrete, and then get all the dust off, make sure it's clean, and then you're able to spray the densifier. In terms of the divots, basically it's little, polished concrete, it can have a little of, I forget the term for it, but anyway, it's basically little pockets, right? And if you leave those pockets and you polish that surface out, you'll see those little pockets. So just like normal polished concrete, where you would need to fill those, we call it grouting. There's several different products out there for grouting. Pretty common one is to use a type of product called a polyurea. Cures really fast. You grout all the little pockets, and then you grind that off. So that would basically be the same process with ours as would be the normal polished concrete. So yes, for both ours and normal polished concrete, you'd still need to actually fill in those little divots.
Awesome. How does the completed cost of Premera compare to a traditional grinding method?
So the biggest cost in with any type of flooring project is the labor, right? And so what the labor is depends pretty heavily on what part of the country that you're in. Basically, the further you go north, kind of the more expensive things get. So we've got our biggest start and have the most market presence in Texas, because that's where we started. And the labor in Texas is basically, if not the cheapest, one of the cheapest in the US, because we have so much labor pool coming up from Mexico. And so we're saving about half the time, and it makes a lot of financial sense for contractors to do it even in Texas. And if it works in Texas from a labor perspective, it really works anywhere else. But just purely looking at dollars per square foot, right? The labor all in cost to do polished concrete up to say 1,500 grit, and say it's a class A exposure, would cost somewhere between $6 and $8 a square foot. How big the area is matters as well, because the bigger the area, typically the lower the cost, because you get some efficiencies there. It's a bigger area, but typically you're going to be somewhere between $6 and $8 a square foot for your traditional polished concrete up to a 1,500 polish. With Premera's system of doing it, you'd basically be cost-wise, product material-wise, you'd be about somewhere around 70 cents a square foot. Now that doesn't mean that's what the final cost is going to be, because the contractor still has labor in there. But typically, final cost of a job is going to be the materials are going to be about 30%. It's typically like a good rule of thumb. So if the materials are 30% and the materials are about 70 cents a square foot in cost, then it's about 3 times that. So maybe you're talking $2.50, maybe $3 a square foot is what the contractor could do it for. Obviously, you gotta work with a contractor to work that out. We just supply the product. We don't get involved in the actual application. But it is for sure a lot more efficient, because there's a lot less labor involved. And so you're looking at basically the long answer short, it's going to be about half the price to deliver our system versus the more traditional process.
Awesome. Are there colors, and can the product hide concrete patches?
So you can stain polished concrete. That's done pretty often. So there's two ways that we can polish stained concrete, well, create stained concrete and then polish it, right? There's the traditional way, which is basically you get a dye, you put the dye into acetone, and you spray the dye onto the concrete, and basically it soaks into the concrete and creates a dye, like a stained concrete, right? It's just the stain that you actually want. And so at that point, you could put our densifier over it, assuming that it's at 100 hybrid grinding level or profile, and then varnish the densifier, and then now you're creating the polished appearance. You can also put the dye directly into our densifier, so you can basically stain, densify, and polish basically all in one step with one product. Creates a little bit more of an efficiency gain. The color's a little bit brighter because there's a little bit more dye at the surface. Contractors won't really mind which way. It's more of a preference to the end user. Do they want a little bit more brighter, richer colors? If so, put it in the densifier, in our densifier. If they want a little bit more muted kind of colors, then doing it the traditional way where you're just spraying the dye onto the concrete first and then polishing it would be the way to go. In terms of concrete patches, that would be, I mean, it depends basically. Concrete can be all sorts of different types of shades. If the concrete patch material is drastically different than the concrete color, then that can be kind of hard to hide. You can do it, you can kind of break up the appearance of it by kind of having like a mottled effect of the stain around the patch. But typically, one thing people can do to help that process in general is take some of the concrete dust that's generated from the grinding process and put that in the patch material. And so that helps kind of mimic the color of the patch material to the concrete itself. So that's something that's pretty common. But really the answer is, we're working with translucent materials. It's not going to be like an opaque stain. And so because it's translucent, if there's too much of a variance between the patch material and the concrete, then it's just going to be hard to hide that.
Okay, awesome. All right, and then what about finishes? Can you obtain a less glossy finish like matte or satin with this system?
Yeah, absolutely. So there's a couple ways to do that. The easiest one of which is to basically just not burnish the guard, right? So you don't have to burnish the guard. You don't like to, and that'll basically create a satin finish kind of naturally, or it's not going to be nearly as glossy as you could otherwise. We are currently working on a matte additive that you could just fairly easily just put into the guard and then just microfiber that on, and then you're done, and then you have a matte finish. Typically, if you did want just a matte finish concrete, we have clear coats as well that can basically just deliver a matte finish to the concrete. Basically, if you want a matte finish, and there's not necessarily a reason to polish it, right? Because the whole idea of polishing is to increase that gloss level to a reflective point. And so we can basically, instead of grinding the whole thing and doing this whole polish process and then bringing it down, we can just start at a fairly non-shiny level of concrete and then apply a matte clear coat that we have as well. Beyond that, another way to deliver a less glossy finished state is to, instead of polishing with a 3000 grit diamond pad, to polish it with like a 400 grit diamond pad, which is basically a more aggressive, less fine type of polish. And so there's several options that you have there, depending on what you need. We can kind of cater the solution to deliver what's required from the customer.
All right. How long does it have to cure? Does the concrete have to cure before applying the polish?
So you want to wait 28 days before you apply our products to the concrete. You want it to cure out, and that's fairly typical for any kind of chemical product that you're putting over concrete. You want it to finish curing out before you introduce other elements to it.
All right. Do you have recommended vendors in the San Francisco Bay Area?
I believe we do. I can get that answer for sure, but I know that work's been done up in San Francisco. So I believe there's a concrete wrapped up there, but I can double check that point.
Awesome. All right, and it looks like this might be our last one. So if anybody else has some last minute questions, feel free to throw them in now. Is there an existing wall? If there is an existing wall base, does it need to be removed or taped off, or should you finish the floor prior to any base install?
Typically you want to finish the floor prior to that. Otherwise you're trying to get as close as you can to the wall, and you have to do that with a hand grinder. And so if you can't get all the way up to that edge, then you know, it's gonna maybe many people wouldn't notice, but you know, contractors for sure notice these very small details where it's like, all right, well, they didn't go all the way to the edge of the wall. So you want to do that so that when you put the base over it, you're covering that section you didn't quite get to with the hand grinder.
Mhm. All right, and we did get one more. So slip resistance was mentioned, but can the floors meet ADA compliant coefficient of friction plus or minus 0.50 as an acceptable SCOF value?
Yeah, so that static coefficient of friction, yeah, 0.5, also dynamic as well. And the industry is largely kind of moving towards dynamic, which is the pendulum test. So we meet those, yes.
Mhm. All right, awesome. Okay, it looks like we might have gotten through all of them. So thank you everyone for such great questions, and thank you, Doug, for an awesome presentation. If anybody has a question that comes up after today's event, you can head over to Acelab and connect with Doug there. There's also going to be a quick post-event survey, so you can add any questions there. Any feedback is super helpful for us. So other than that, just everyone, before you log off, I threw some links in the chat that might be helpful, so feel free to grab those from the chat before you head out today. And that should be it for me. I hope everyone has a really great weekend, and thanks again, Doug.
All right, thank you guys. Take care, everyone. Have a good weekend.